In this video, I'm going to look at the lesson 10's course content. Then after the quick review of the course content, we're going to look at the homework together as well. So first, two samples estimated the difference between two means. So this one actually, the first lesson line, we'll look at the estimate on one means value. Right now it's two means. So what do we do if we have two samples, x1 and x2? Okay, if x1 and x2 are mean of independent random variable size of n1 and n2. So first, if the sigma 1 and the sigma 2 are known, if sigma is known, we know it's going to be a normal distribution. So previously we got that x bar minus mu over sigma over square root of n. This is normal distribution, right? So now what do? We have two variables. It will be very simpler. If you look at this, it will be very similar actually. So you get x1 minus x2 bar, which is the difference between the sample mean, and minus, if we got this previous is the one for one sample. For two sample is x1 minus x2, okay, minus mu1 minus mu2 over square root of sigma 1 square over n1 plus sigma 2 square over n2. So this one upgrades to standard normal distribution. So we're going to have the confidence interval, which is mu1 minus mu2 is less than x1 bar minus x2 bar. This is given, this is given. So we just need to find out z alpha of 2. This is from the table. The z alpha 2 from the table. Sigma 1 square over n, sigma 2 square over n are all given in the problem. So the other one is subtraction, x1 minus x2 bar, the difference, minus z alpha of 2, and then multiply by the sigma 1 square over n1 plus sigma 2 square over n2. Okay, so there is an example in the example 9.10. You can look at this example. And everything is given as what I said. It tells you x1 minus x2 minus x1, the difference between the sample mean, and also give you the sigma 1, sigma 2, both are given. What you only need to find out is the z alpha of 2, is z 96%, which because it's going to be two sides, you actually need to find out this is 96%, but the table will give you everything until this point. Actually, you are looking for 0.98. Okay, 0.98, the z what value give you 0.98. It turns out z 2.05 gave 0.98 as a probability. Okay, so that's the only thing you need to find here. Everything else is given. Then plug into the formula, that'll be enough. So similarly, they also give you a formula to find out if the sigma 1 and the sigma 2 are unknown. So we have if sigma 1 and sigma 2 sigma 1 and sigma 2 are unknown, I think this T distribution, yeah. If sigma 1 and sigma 2 are unknown, but sigma 1 and sigma 2 are equal, okay? They're equal but unknown, so we're going to use a T distribution. This is a T distribution formula. The next page 288, you have the T distribution formula. Everything will be given as well. X1, the sample mean difference, the T value will be given. N1, N2 are known. So we need to find an SP. So SP is, this is N minus 1. This is SP formula. Okay, then everything is given. You just plug into the formula. It's not really hard thing to do. I want you to try all of them, but try all of them at least once and understand how to apply the formulas. The next one is sigma and sigma 2 are unknown again. They are unknown, but sigma 1 and sigma 2 are not equal. So this is very similar as the normal distribution now. It's minus T alpha of 2 square root of S1 square over N1 plus S2 square over N2. So we find T alpha of 2. This is given, this is given, this is given, this is given. And less than mu1 minus mu2, less than x1 minus x2 bar, and plus T alpha of 2. square root of s1 square over n1 plus x2 square over n2. The only thing you need to find is use a table, find the t alpha value, t alpha of two values. Okay, so 9.9 is paired observations. Paired observations, basically, when do we use the paired observations? We want to compare these two populations if there's any difference. For example, a group of people, they get some disease, or for example, they get a fever. And after they take a certain type of medicine, or they take some medicine, then does it treat that symptoms or not? Before they take the medicine, what's the temperature? After they take the medicine, what is the temperature? So it's kind of like using the observation of the same group of people. What's the effects on the same group of people? Okay, so it can use for many other problems in the real world. Okay, so for example, we have some new strategy, okay, promotion strategy for sales promotion, for selling products. And before we have this promotion strategy and after we have this promotion strategy, so do we have a obviously increase sales as a sales result? So we want to know if this strategy actually works, or actually is effective or not effective, based on the same group of products or same group of people. So what is this is basically used for the observation. We do something, if there's anything change. If this is effective, then if there's something it does have some change, which means this method is effective, right? So that's the whole thing of the chapter section 9.9. So basically, we do have the difference D normally will be given to you, or if it's not given to you, you can use your calculator or you use a software to find the difference, minus T alpha of 2, which can be found from the table, and SD, which is the variance. For example, I give you 1, 2, 3, 4. The other one give you 1.1, 2.1, 3.0, 4.5. You have two group of data, the same thing, and then you can find the mean value of this one. You can find mean of this one. You can find D between these two. You can find the standard deviation. The variance between the difference. The variance of the difference of this one, 0.1, 0.1, 0.5. Now you can find the difference of these four difference numbers, right? This is the difference. So basically everything will be given except the t values. Then you plug into that and you can find out the SD over square root of n. Then you can find out this UD confidence interval, right? All right. So there's another example. In the course content, I also give you example as well. And you can read the course content and finish the problem. And everything is given. You can find that, and then you got the final answer, right? And section 9.10, single sample estimate a proportion. So basically, in this case, we're going to use. It's kind of like a proportion. It's not like a mean value of a group of data. It's a proportion value. What is a proportion? Proportion is like successful ratio or successful and like a failure ratio. It's kind of a ratio stuff. It's between the proportion actually is less than 1, bigger than 0, right? Okay. So the unknown proportion is not expected to be too close to 1 or too close to 0. Normally proportion is like a 0.6, 0.8, like a ratio, right? Okay, so the proportion actually is, if you look at the previous one, we did also have the proportion is a we can use a standard normal distribution. Okay, so what is the proportion formula? We have the proportion. You have also proportion mean value. This is the sample proportion. For example, the passing rate of the class. Okay, then the passing rate of the whole college, and the passing rate of a certain class, a several classes, is kind of like sample proportion. A minus z alpha of 2. Normally, this will be given to you sample proportion, and the p, q, And if the p is given, then the q equals 1 minus p over n less than p plus the alpha of 2 times square root of p q over n. Okay, so there is some examples here. Well, I'm not going to explain the examples detailedly. I think once you know the formula, you can plug it in. It's not really hard to explain or to read how to plug in because everything is given to you. What you need to do, the only thing you need to worry is find the z alpha values. We have done a lot of examples in the previous chapters about z-score. So everything else is given to you except the q, but q is 1 minus p. You got, so n is given, p is given, q you can find 1 minus p, z alpha 2 find from the table, then that's it, right? So it's not really a hard thing to do. And also there's a sample size formula, n equals z alpha of 2 square p q e square. Another formula for the sample size. Okay, but in the homework I will introduce to you how to apply the formulas, how to use the static crunch to do all of these problems. Okay, so all of this is just the application of formulas. The section 9.11 is estimate the difference between two proportions. It's the same thing as the estimate of the sample of two mean values. So it's the same thing, actually very similar. P1 minus P2 and minus z alpha, because it's not normal distribution, pq over n1 plus pq over n2, you know, and then less than p1 minus p2. It's very familiar to you, right? P1 minus p2 and plus z alpha of 2 square root of pq over n1 plus pq over n2. So it's very familiar, like the previous sections, previous homework, right? So it's the same idea, and everything will be given to you when you do the problem. Okay, this is the estimation of the proportion, the difference proportion. Okay, so once you do one sample and then two sample, is a very familiar formula. I want everyone to use that formula, at least do at least one problem yourself by handwriting, then use the static crunch to do all the homework problems. Single sample estimated variance. So the variance, single sample variance, we want to estimate the variance. The variance, if we look at the variance, is you can say the confidence interval, the variance. Okay, we can estimate the population mean value. We can estimate the population variance. So the variance, we can use a chi-square formula. 1 minus chi-square 1 minus alpha of 2 square and n minus 1 s square bigger than chi-square alpha of 2 square n minus 1 s square. So in a problem, it asks you, for example, 9.18, the following are weights given these 10 package weights, and find the 95% confidence interval of the variance of the population. Okay, so basically you can find out the variance of the 10 package, and what you need to do next is just find out the chi-square alpha 0.025 and the chi-square 0.975. Then plug it in, you can find out the sigma square formula. And also 9.13 is the ratio of two variance. Basically, use F distribution for the ratio distribution. So F sigma 1 square over sigma 2 square is ratio, and it's less than S1 square, S2 square, F alpha of 2, V2, and V1. Okay, so I will explain how to use a static crunch to work on all of these problems. Okay, so all of these problems you can use static crunch to do it. But I strongly recommend you look at the problems and do some problems by your handwriting instead of just purely working on the static crunch. Okay, so I think this is all of this. Maximum likelihood is optional. You can read it. But that's for the introduction of this whole second lesson. I would recommend you reading the whole textbook and working on problem, at least one problem for each section, to understand the application, understand how to apply the formulas, understand when you're going to use it. Okay. Next, we're going to look at the homework problems for the next video. Okay.